what we're going to talk about today basically is a high-level overview and discussion around the mechanism changes that have recently gone into the UMA 2.0 upgrade, specifically looking at the contract changes and the protocol changes. So there's been a lot of work put into other things, such as like a really nice new DApp and a new website and a whole bunch of other stuff, but this conversation and presentation is primarily aimed towards the protocol changes, so mechanism related changes, tokenomics, these kinds of things. And this content here we can see basically aligns with what I just said, and we've got some other changes around quorum requirements, which we call the SPAT and the GAT, which we'll get to later, vote delegation, emergency recovery, and a few other interesting things that have been changed in the protocol. Cool. So yeah, what was this DVM thing again? This thing that we upgraded? So this, if you don't remember, is the UMA arbitrator, effectively. It's the data verification mechanism. And this is used by all UMA products to actually arbitrate disputes and to facilitate dispute resolution between participants of a dispute. And the way this works is using a commit reveal shelling point oracle in which UMA token holders vote. And this is the key component of the system that has been upgraded in the 2.0 upgrade. So there was this meme from back in the day, early 2020, and it's this DVM thing, this thing that everything else is built on top of within the UMA ecosystem, that is upgraded. That's what we're talking about today. Okay, so let's start at a high level. So at a high level, what has recently been changed is the introduction of three main categories of change. Firstly, we now have a staking and slashing mechanism where voters now earn a pro rata share of emissions for participating within the DVM system. This is really the crux of the change around how rewards interplay with votes. And we're going to spend a lot of time digging into the details there. We also have a reworking of a lot of the core adjacent contracts within the UMA ecosystem, such as the governor, the proposer, and the designated voting system, which we'll touch on briefly. And there's also a completely new component of the DVM now called the emergency recovery mechanism, which enables the DVM to recover from certain kinds of failures, which are theoretically possible, hopefully never happen, but it kind of acts as like a safety net that underpins the DVM. So let's talk about the mechanism and tokenomics changes. This is the primary crux of what's been changed in this upgrade and what the majority of this internal learning session is going to be focused on. So there are three main changes in terms of how the UMA token works within the UMA system post this update. The first one is that in order to earn rewards, voters must stake UMA within the DVM to participate. Okay, this involves actually locking up your UMA within the DVM. And once you've done this, you then earn a pro rata share of a fixed emission rate for being staked. Okay, now this is very different to the previous system where rewards were earned based off the number of votes. It's now a pro rata share of a fixed emission. And then thirdly, once staked, you are now susceptible to slashing or reallocation of rewards between participants, which could either be a positive thing or a negative thing depending on how you behave within the system. We'll dig into how that works very shortly. So let's talk about staking to begin with. Firstly, like I mentioned, to earn rewards, you must stake. And also to vote, you must stake. And this involves locking your UMA within the DVM. And this can be done for a minimum duration of 7 days. So you stake your UMA, and in order to access your UMA again, you need to submit an unstake request, and that takes 7 days to process. The reason for this lockup is primarily to protect against a number of weird system attacks or weird mechanism issues that present themselves in staking systems when you can instantaneously stake and unstake. For example, you could imagine someone unstaking right before a vote to avoid slashing and then restaking right after the vote. So yeah, that's why we have this delay. It also kind of makes the mechanism a little bit harder in the sense that in the event that something was to go wrong with the DVM system, participants who are staked are kind of with the system. They can't immediately unstake and sell effectively, right? And this kind of further aligns incentives. And yeah, it also enables some of the other stuff that we'll talk about shortly, which is around slashing. So that this like being like forcibly stuck in the protocol is a prerequisite to facilitate slashing. Okay, so that's the first mechanism chain, staking. Now let's go over rewards. So while you're staked, you're entitled to a pro rata share of emissions. The way this works is that we effectively inflate the total UMA supply at a fixed UMA per block rate. And the number that was voted on when we upgraded the DVM earlier was 0.18 UMA per second, right? So that's the amount of UMA that is emitted per second and is allocated pro rata based off of your stake size. So if there's 100 UMA staked and you have 1 UMA staked, then you will earn 1% of 0.18 UMA per second, right? This is conceptually equivalent to pretty much any other reward staking system that we've had in the past within DeFi land, such as like the synthetic staking contract or whatever, conceptually very similar. And this number, 0.18, the goal was to sort of target the previous historic DVM APY so that conceptually there wasn't this like big discontinuity between previous rewards and new rewards. And the benefits of this change are pretty big. The main one, or a very important one, is predictable and deterministic APY. And this is important because in the previous system, it was actually kind of hard to know how much you're going to earn for being an actor in the system, right? When you participate in the DVM, you're doing work, right? You're validating things, you'll have funds at risk, you're doing all of these things. And it was difficult to know previously, how much am I going to be paid for this? Now it's much easier to know because you can look at the emission rate, the total amount of UMA staked, how much I intend on staking, and calculate what your rewards are going to be. That's really cool. The second big thing is that this change decouples how much you get paid from how many votes there are. So in the previous design, there was this incentive issue where if you had a lot of UMA, there was this attack that fortunately never really happened, but the system was vulnerable to this, where someone could create many spurious or useless requests to sort of artificially generate rewards for themselves, right? But by decoupling how much you get paid by how many rewards there are, there's no longer the ability to do something like that, right? So you are now paid for being a staker, and how you vote is treated as a separate concept. And we'll see the delineation of these two ideas when we look at some of the slashing logic later. So just to quickly look at like how simple the rewards are, and to just give a bit of an intuition around this, basically how much you get paid is a function of how long you stake, how much you stake, the emission rate per block, and how much is staked in total, right? Kind of makes sense. And if we have 20 million UMA staked and the UMA emission rate is 0.18, then that works out to an APY of 28.3%. And obviously you can multiply the numerator in this equation by how much you have staked even the output of it, and you will get your rewards over a year. And that's basically the way to think about it. It's not continuously compounding in the sense that you don't accrue rewards on accrued rewards, but this is possible to achieve if you claim your rewards and restake them. Yeah, there are many reasons why it was designed that way, but the main thing is that it just keeps things a lot simpler to reason about, and the implementation is a lot more efficient and easier to reason about. Let's talk about reallocation. So reallocation or slashing, two different words for the same thing. I want to preface this by saying that it's not scary and people shouldn't be afraid of it. It's designed to not be that punitive. We'll get into the details of that in a second, but just to preface this, that this is not like meant to be like a super adversarial mechanism. So the way it works is once you stake within the DVM, you are now susceptible to being slashed, okay? Your base staked UMA is susceptible to being reallocated. Let's word it that way. The way that this works is that tokens that are staked are reallocated from voters that are either inactive or vote wrong to those that are active and vote correctly, okay? So if you stake and you're just passive and you do nothing, or you stake and you're going against the shelling point, then you are punished, and those rewards that stake is reallocated to those that do the thing correctly. And this is kind of the core mechanism change in addition to the staking logic that hardens the shelling point, because what it does is it rewards those that behave correctly more and punishes those that behave wrong in a very direct way. We kind of implicitly had similar mechanisms in the previous version of the DVM, but it was more of an implicit like cost function, right? If you voted correctly in the previous system, you would get rewarded directly. But if you voted wrong, the penalty was more indirect, right? There was like an opportunity cost, or the rest of the UMA token supply sort of inflates away from you. But now in the new design, you're directly penalized for doing the wrong thing. And this is good, right? Like direct incentives for the wrong behavior hardens the shelling point and overall makes the system more robust. Now, one important detail is that governance is not considered slashable for voting against the majority. And the reason for this is that we want to consider governance as a democratic process. It's not a shelling process, right? If I ask the Oracle what is the price of Ethereum at a certain timestamp, there is one correct answer if you have a very clear methodology of computing that. But the outcome of a governance action, by very definition, is open to interpretation, and we shouldn't punish people for voting against the majority. We do still slash or reallocate governance requests if you're inactive, but yeah, that kind of makes sense, right? If you're sitting on the sidelines while a governance action is going on, you should be punished. So let's talk about how reallocation is calculated. So there are 5 things that go into the calculation of a reallocation number. The title in this slide is slightly wrong. There is how much UMA is staked in total, how much UMA voted, how much UMA voted correctly, whether or not the request in question is a governance action, and what the index of the price request is. So basically, with these inputs, we can work out how many tokens participated in a vote, what percentage of the tokens participated correctly in the vote, how contentious the vote was, and using the price request index, you could in theory construct more dynamic kinds of slashing. For example, you could say requests from a certain integration or a certain like domain or of a certain identifier, any information about that request influence how the slashing works, right? So effectively we can consider like the context of the vote in calculating how the slashing operates, if that makes sense. So we'll look at some examples in a bit, but basically, if you consider like all the inputs that goes into a vote, we can use those to work out how the reallocation of stake should be treated. Okay, like I mentioned earlier on the first slide on this, we've designed this such that in the beginning, things are meant to be really simple, easy to reason about, not very punitive. And we kind of want the penalties to approximate how much rewards you would have earned for some sort of staking duration, okay? And this means that if you stake in the beginning and you don't vote correctly or something goes wrong or whatever, we don't want the penalty to be that you lose all of your UMA. We want ideally, in an ideal situation, sort of the amount that you earn is approximately how much you lose, right? Something in the sort of ballpark. The parameters that we started with, that the DVM is running with today on mainnet, are actually less punitive than this. We're currently slashing at 0.1% of your total staked amount per incorrect or per missed vote, right? And each voting round could have multiple votes. So each request that comes up in the voted app is a separate vote, and each of these are susceptible to 0.1% of the staked amount per vote. Now, if you work it out, this amounts to being slashed approximates about 1 day and 7 hours of rewards, right? So if you're staked and you miss 2 votes, you then miss 2 days and 14 hours worth of rewards. That's really not that punitive, right? You make back the slash very quickly. And again, by design, because this is a new system, it is potentially scary, and we want to sort of ease into how we think about these reallocation. Now, the way that reallocation works is pretty simple. We basically take how much you have staked, multiply that by the number of incorrect votes that you participated in, multiplied by the slashing rate, and that gives the slash per voter per round. and then we can work out the total slash across all the voters, and then we reallocate that, the positive slash for correct voters per round, by simply taking the reallocation of that amount. So your pro rata share, right? What is the total amount that was slashed over everyone that got wrong, and how much did you have staked divided by how much was everyone who staked and voted correctly? Basically, like, what share of the slash are you entitled to? And like I mentioned earlier, just to double click on this point, at launch, we do not slash governance for the reasons mentioned earlier. Governance is democratic. It's not a shelling point. One thing I want to say as well is these numbers, 0.1%, 0.18% emission rates, like, there's some magic numbers in the system, right? It's difficult to choose magic numbers, and we kind of chose things that made sense, but all of these parameters are open and subject to governance, and maybe they get changed in the future. So an example of something that I think could be an interesting concept for us to play with is this idea of quadratic slashing, where we could basically change how slashing works as a function of the participants' behavior in that round. So, like, the example that I think is like really sort of illustrates this point. Imagine you designed a system where the more contentious a vote is, right? So the closer it is to like a 50-50 outcome, say 60-40, for example, then the more you want to slash people who were staked but did not participate, right? For example. And the reason is, in those kinds of contentious outcomes, you sitting on the sideline is sort of more detrimental than if it was like 95.5% outcome, right? So that's like an example. And with these inputs that I mentioned earlier, we can design these kinds of systems, and we can sort of play with the design space to see what creates the best outcomes, what is the most easy to understand, and also, what kind of builds the best oracle, basically. And yeah, starting with simple, but can always build on top of this, and governance can control these properties of the system. Let's talk about vote deletion for a second. This is a new concept in the DVM 2.0. In the previous system, there was no way for a vote to ever be removed from the DVM. There is this concept in the previous DVM and in the new one called vote rolling. Now, the way a vote rolling works is basically if a vote does not reach quorum, then the vote will roll into the next round. And that means that it can be voted on in a following round, right? So we'll talk about the quorum requirements in a later slide, but just consider if it doesn't reach that requirement, then it rolls, okay? In the previous system, it could roll indefinitely. In the new DVM, we've changed it such that if a vote rolls after a certain number of requests, then it will be automatically deleted from the system. The reason we've added this is due to the incentive change that we added around the decoupling of rewards and the number of requests. The DVM is now susceptible, without deletion, to being susceptible to a denial of service attack, effectively. You could spam the DVM, create a whole bunch of requests, and then you hit this situation where it's actually no longer gas efficient for you to participate in the vote. Basically, you're going to spend more on gas than you're going to lose, right? Imagine there's 1,000 requests in the DVM, right? It's going to be very expensive for you to participate in that. So to address this, what we've done now is created a system where we can intentionally choose as participants in the DVM to delete a request if we consider it spam. And the way that would work is the majority of people need to agree to roll the vote, and we roll it a couple of times, and then the system will purge that request from the system. And you could imagine doing that en masse if there's like 100 requests that are all spam, right? And the DVM participants all collectively agree that this is noise. We do not want to consider this as a valid request. It can be deleted. So it's kind of like a defense mechanism that the DVM has against spam and sort of abuse, right? Which previously we didn't really have. So there's a very kind of nuanced question that comes out from the ability to delete via rolling, which is how quorum is reached. And we'll dig into that now, and then I'll double back onto why this is related to vote deletion. So let's talk about quorum. Quorum is basically the conditions that a system needs to reach in order for it to agree on the next step, the evolution of the system, right? And in the DVM's case, we're talking about under what conditions does a vote resolve. So someone asks the DVM about the price of Ethereum. At what point does the DVM say this is the price of Ethereum, right? That's the quorum requirement, the thing that needs to happen for the DVM to make a decision. In the previous design, we simply had a minimum number of participants that needed to partake in a vote to meet quorum. This was called the GAT, okay? And this GAT, this magic number, maybe it's called governance activation threshold, god-awful threshold. It's kind of a weird acronym that we never really well defined, was set at 5% of the token supply. So that means if there's 100 million UMAs in circulation, for example, we need at least 5 million UMA to participate in a vote for it to be resolved. And this was irrespective of the distribution of the tokens that voted. You simply need the total number of tokens that participate in the vote to exceed this threshold. That was the only quorum requirement that the previous system had. In the new DVM, there are 2 quorum requirements. We now have changed the GAT from being a percentage to a fixed number. Okay, so the number of tokens that participate in a vote must meet the GAT. So a similar concept, but the difference is it was a percentage, it's now a fixed number. I'll talk about why it's fixed from a percentage in a second. And then the second component, which is a change, is we now introduce the SPAT. So the percentage of tokens that vote in a particular direction must meet the SPAT. So this is around percentage of staked tokens that must agree on an outcome. And in the current DVM deployment, this is 50% of the staked UMA tokens. So consider that there are 20 million UMA tokens staked. Then we need to meet 2 criteria to hit quorum. Number 1, at least 5 million tokens must vote, full stop. Number 2, 50% of the staked UMA tokens must vote in the same direction. So 10 of the 20 million UMA tokens must all agree on the outcome before the vote resolves. These numbers basically mean that the 5 million GAT is like a less strict requirement in this example, where the number of UMA staked is 20 million. But if the number of UMA staked is much lower, then the notion of GAT and SPAT and the interplay becomes more clear. So consider that there's only 1 million UMA staked, right? Now, because the GAT is a fixed number of 5 million, you actually can't reach quorum until there is more UMA staked. And so this shift from a percentage to a fixed number was done to accommodate sort of the cold start problem that a staking system like this has, right? In the beginning, you could, in theory, control the governance outcome with a very small percentage of the total supply. So the combination of the GAT and the SPAT bounds the minimum number of UMA that must be staked to reach quorum, effectively the GAT, and then the SPAT ensures that a certain percentage of the staked tokens all agree with the outcome. Now, the interesting property of the SPAT is that it introduces a shelling point on the notion of do nothing, right? The decision to roll a vote. And the way that works is that we need to actually collectively agree, if we want to roll a vote, to not vote, right? The shelling point is to do nothing. In the previous DVM, when there was no SPAT, there actually was no shelling point around the decision to roll a vote, right? If we wanted to all roll a vote, we would just not vote. But the shelling point now shifts from the majority outcome of whatever is voted to just the GAT. So, for example, consider in the previous DVM that we had 20 million UMA participating in a vote, right? That means that to reach quorum, we would need, if we have like, let's say 50%, or let's say a full amount is voting in that particular direction. So you've got 20 million UMA voting in a direction. If we want to roll the vote, it only takes the GAT amount of UMA to push it through. So if everyone is sitting on their hands and they're saying, we want to roll this vote, it would only take someone with 5 million UMA to push through a vote and effectively prevent it from rolling. So the introduction of the GAT and the SPAT in conjunction creates this shelling point around the decision to roll a vote, which is really important if we use rolled votes to delete votes, because we can now have a shelling point around the DVM does either not know what the answer should be, or this is spam and we're going to keep rolling, right? Which is kind of a cool mechanism. Now, I maybe skipped over this on a previous slide, but there is a max number of votes, max number of times that it must be rolled to be deleted. And this is set to 4 in the current deployment. So that means that it needs to roll 4 times in order for a vote to be deleted. Okay, so that was a lot. I'm going to pause now before we go on for a second, just to see if there's any questions. We're like halfway through the time. We've gone through most of the mechanism changes. I've unmuted my audio. Any questions on quorum requirements, delegation, staking, any of these things?
Also, some people may have been muted by me or some other admin. So if you want to ask a question, but you're muted, just, yeah, say so in the text hub.
Okay. That's cool. We can keep going, and I'll open some space later for questions. So let's talk about delegation. So now we're kind of out of the mechanism kind of content and talking a little bit more about some of the features. So the DVM now has first class support for delegation. And basically what this means is you can take one wallet and empower another wallet to do, or another address to do certain actions on your behalf. In particular, committing, revealing, and claiming and restaking rewards can be done by another address. So a really illustrative example would be you have a hardware wallet that you leave in a safe, for example, that you stake with, but you still want to be able to vote easily, right? And it's irritating to have to get your hardware wallet all the time. So you delegate to your phone, a wallet on your phone that's like definitely less secure. But because the permissioning on the delegate wallet is lower, this is acceptable, right? So your phone can then commit and reveal and claim and restake your rewards, but it can't actually access any of your underlying stake. It can't withdraw your stake, access your rewards directly, or anything like that. And this is kind of like a very nice use case when it comes to individual stakers, but it also drastically opens up the design space of what can actually be built on top of the UMA protocol. So you could now, in theory, build like custom delegation logic out of protocol where people lock UMA into a contract and there is some delegation system. And now we have like X UMA kind of thing where you just stake UMA and it goes up and you don't have to actually participate in the vote. We're not going to build this as a part of the protocol, but this delegation flow could enable someone to build something like this if they wanted to. And it also means you can do things like if a treasury or a DAO has a bunch of UMA, they can stake it and then delegate to maybe a trusted member of their protocol, or maybe to a contract that requires some combination of other participants to stake on or to vote on. And it basically means like treasuries can stake and vote, right? Which is really interesting when you start thinking about like the design space that opens up with treasury swaps and other kinds of things that we could use the DVM and the UMA token to power. Yeah, so very much an open field around delegation, something that I'm really excited about because I think it opens up a pretty interesting design space of future things that could be built on top of the DVM. Okay, emergency recovery. So I briefly mentioned this earlier. Let's go into a little bit more detail now. So this is not like a super thing that I think we should emphasize too much, but it is a good thing to know about. Basically, the DVM now has a special recovery path that enables the DVM to recover from certain kinds of breakages or failures. Imagine, for example, the DVM fails in some way where we can't commit, reveal, we can't stake or unstake. Basically, it breaks in a way that is bad, right? This recovery system enables us to, in a decentralized way and in a permissionless way, recover from this process. Now, the way that the flow basically works is that someone needs to post number one, a very large bond, right? And I think the parameter is set to 5 million UMA, step one. And this bond is accompanied with a transaction payload that they want the DVM to execute. That payload then enters into a liveness period of 10 days. During this period, DVM participants can choose to vote down this proposal and effectively delete their bond, right? So it goes to the store. So you basically spent 5 million UMA and it got deleted if you try and do this nefariously. And what is important about this is if you submit this proposal and the DVM is still working, then the DVM participants will vote it down, right? Like that's like the economically rational thing to do. This system should never be used if the DVM is working. And the simple reason is like the participants will vote it down if it's used incorrectly, right? And by definition, that means that if the DVM is working, you can't use this emergency recovery system. However, if the DVM is broken, then it can get through the 10-day liveness period. So that means that only when the DVM is broken can we pass the liveness period and can it actually get to the next step. So after that 10-day liveness period, the emergency recovery action can then be executed. Now, there is a small amount of permissioning put on this, and that is that there is a special UMA multi-sig address that can execute this recovery. Okay, no other account can actually execute the recovery. The main reason is just out of an abundance of caution that we want to make sure that we can control the timing of it, and in the event that something very bad was to happen, we can kind of be completely confident that this is correct. And this multi-sig is owned by the UMA Foundation and is a publicly known address and all of that. It's really important to note, though, that this does not empower the protocol to do anything other than execute the emergency action. It cannot propose it, right, directly. It still needs to go through the 5 million UMA bond. It still needs to pass liveness without being voted down by the participants. All it can do is censor the execution of this emergency recovery process in the extreme, which we think is an acceptable trade-off given sort of the overarching power that this emergency recovery system enables. Okay, so those are some of the other features. Let's pause for some questions now. I'm sure there are some questions around some of the mechanism stuff. I did go quite quickly through some of it, and let's go on anything where anyone's not sure about stuff.
Maybe it's worth talking about why there is a one-to-one relationship in delegation, Chris, and what your thoughts are on, I don't know, future delegation systems that look more like other voting delegation systems out there where there's one delegate for many delegators.
Mm-hmm. So the main reason it's built like that one-to-one in the core protocol is that it's like by far the simplest way to do it, and it doesn't make the contracts much more complicated and doesn't increase gas cost. And importantly, any kind of system like what you just described now, Sean, could be built on top of this. You would just do a one-to-one delegation between like whatever the delegation, like the store of the tokens is. Like maybe this is a multi-sig or a protocol controlled by some other system. And then you would delegate to a smart contract, right? And then that smart contract could then have any other kind of aggregation logic that you talk about. So, this could be maybe you have another token that has weighting, and based off of that weighting, you vote with the delegators tokens, right? Or it's like another protocol and you use their other protocol token to vote within the UMA system. The point is that any complicated logic like that does not need to be built within the DVM directly, right? We want the DVM to be this kind of kernel of the system, and it's designed in such a way that this complexity can be built externally and integrated within the DVM.
Cool. Thanks.
Any other questions or comments or anything anyone wants me to clarify? Okay.
Paul asked a question in the chat.
Mm-hmm.
I don't know if you saw it.
I can't see the chat. I can just see my screen. So if you could, I don't know, read it to me maybe, or.
He said, would it be possible to delegate only reveal capabilities, so permit a central actor to automatically batch reveal via multi-call?
Yeah, it's a really good question and a really interesting idea. So the way it's structured now, the answer is no. But you could build a contract similar to what I described now, that you basically delegate to it, and it has permissioning on what part of the commit and reveal flow it can do, and then it does the reveal only, right? Effectively. The contracts are designed such that you can actually commit with your delegate and reveal with your delegator. So it would be possible to do this. The idea of aggregating reveals and then revealing them in a batch is something we've thought a lot about, but decided to not include in this change because that's more of like a usability thing rather than a mechanism change. And we wanted the primary update here to be mechanism focused, and usability stuff to come a little bit later. But this is something we've thought a lot about, like the design that we think is really appropriate here. You could imagine like all UMA participants that have under some certain threshold of UMA can use this delegate reveal system. So it's like single shot voting, basically. You commit and then you reveal sort of behind the scenes in the DApp, and you give it to like a central operator. And then it reveals for you, but maybe we limit this to only being people that have like less than 500,000 UMA, for example. There's also been like an amount of progress with time lock encryption since we originally designed the DVM in 2020. So I think that could be another avenue to explore. But for now, this was not like the primary goal of the update. But I do think that the delegation system could consider a feature like this, given how it's currently structured.
But also just want to add that like there's this balance between convenience and like security, and we've long felt that privacy, like being able to vote without other people knowing what you're like, forcing everyone to commit before other people know what their votes are, is really important, so that you don't have people just following voters. So like you don't want the first voter to effectively decide what everybody else votes because everybody's just practicing vote following to kind of game the Schelling point. So it's actually quite important that votes are private until they're revealed. And we think this is an important economic property of the system. So whatever system to do this sort of batch revealing or centralized, operator revealing would need to at least preserve some of that privacy during the commit phase. And so what we're really kind of getting at here is that it's like it's hard to do this while preserving privacy.
Yeah.
And I think that's part of the reason we didn't do it in this phase, is just because it's a really complicated problem that probably needs to be solved kind of on its own, separate from these mechanism changes.
Okay, anything else? I do have one or two other slides as well, which I can quickly go through. So just a quick meme to wrap things up. But the other thing is I wanted to just quickly touch on, which I'm sure all of you have seen, but I wanted to just give it a little bit of space, is this amazing new voter app that we've got, which I think is awesome. And if you guys haven't seen all the features, I've got some screenshots of my favorite ones. So the main thing that I think is really, really interesting in this new DApp versus what we had before is all the extra information we now provide voters, right? So breakdowns of participants, detailed information around where the request came from. So you can see here like the chain and the oracle type that it came from. Things like this, voting options and a drop-down list for voting types, which hasn't worked 100% in the previous two votes because of the structure of the ancillary data from Polymarket, but should be correct in going forward. And like sections like this, where we have very detailed information about like the Ethereum mainnet request, the optimistic oracle URL links, the layer 2 links for cross-chain stuff. Like this kind of stuff is like a 0 to 1 improvement versus the DVM 1. And then the other thing, which is really,
Chris, are you intending to show something on your screen, or we're just seeing the vote delegation slide still?
Oh, really? I've changed this.
I don't know if that was just me.
No. Thank you for calling it out. Can you not? I changed the thing. I don't know.
Now I see it. Yeah.
Now you see it? Can you see the screenshot now?
Yeah, I see like a yes or no query and like the vote details, but it just popped up after I asked the question.
Cool. Sorry, I don't know. Discord screen sharing apparently is janky, but so this was the first screenshot I showed when I was talking about those related things. This was the second one. And then, this one with like the specific information. And then, what this one has, which is really interesting if you guys haven't seen this yet, but we now have the ability to show the payload that's going to be executed in a governance action. So you can see here like the function that's being called, as well as the parameters being called to that function. That's pretty cool. And then lastly is the Discord integration directly into the voted app. So being able to see the discussion around a particular question within the voted app to try and help people figure out what their stance on a particular question is. And then delegation as a first class part of the DApp, where you can modify your delegates delegator relationship and do the thing. And that's all this